Hello everyone. My name is Amparo López and I am professor at Department of Hydraulic and Environmental Engineering at Universitat Politécnica de Valencia. Today we will be speaking about the operating point of a hydraulic pump. When we finish today, we will be able to learn how to apply Bernoulli's law in the water distribution network, taking into account that we have a pump, and to understand what is the operating point of this hydraulic pump in this particular system. So we will be speaking about the hydraulic pump in the pressurized pipe network, the characteristic curve of the machine, the application of Bernoulli equation, the operating point, and finally the conclusions. So, what is the hydraulic pump in the pressurized pipes network? First of all, we must consider that to get pressure, we need to have pumps. Hydraulic pumps can be in several types, but these are machines which gives pressure and flow. It can be given in terms of turbo machinery, which are the pumps which we are considering for this research, in terms of centrifugal, which are radial pumps, diagonal and axial pumps, which have the flow in the axial direction. So in this case, the machine is represented by its characteristic curve for them. So the paper, the role of the hydraulic pump is to provide flow to arrive to higher pressure systems in terms of energy given by power, which gives flow and pressure for the liquid to come from point A to point I. So this flow and this pressure must be given by the machine in order to achieve the requirements of the system. So in one side, we have the characteristic curve of the machine. The machine is represented by the curve of this relationship between flow and pressure, this relationship between power and flow, and this relationship in terms of cavitation curves and flow. So the main curve represented the characteristics of the system is the characteristic curve, which represents, in this case, this action of flow versus pressure, which is here on the top part of the supplier curves. On the other side, we have the system represented by the resistance curve of the system, which for more flow requires more pressure because we have losses across the system. So the achievement of Bernoulli's law, what says is that the energy needed for the system to go to higher points with higher pressure must be given by the pump. The pump must have sufficient head to have more head than the geometric head and more head than the losses head. So in this case, when we apply this intersection in between the curve of the system and the curve of the machine, we have the operating point, which gives us the operating flow and the operating head in this particular system, achieving the Bernoulli's law, in which this flow and this head satisfy at the same time the equation of the pump and the equation of the system across the resistance curve. And this intersection makes us to know in which particular point the system will be operating. So what we did is that we have to select each point of the pump in relationship with each point in the system, and when we interact, we will have several operating points. We, as selectors, should choose the best point nearest to the best efficient point in which the power has the optimum performance of the system, but this is independent of the operating point. So what we said is the pumps must be selected according to the morphological conditions for the operation point, and this is the relationship of flow and head at which each system will be operating. These conditions will be accomplishing Bernoulli's law, and we must consider also another consideration related to efficiency and related to cavitation to choose our pumps, but always in a particular operating point, in a particular operating conditions for a particular set point. So I hope this was of interest for you. Bye-bye.